In this short video, I'm going to demonstrate an exploit to de-anonymize the rolling proximity identifiers broadcast by an app running Google's exposure notification. For this demonstration, I'm using an Oppo phone, so more precisely Oppo Reno 2Z, running the latest version of the ColorOS, so this is version 7.1, which is based on Android 10. And for this phone, it has received the latest security patch, which is the September 2020 patch. For the test app, I'm using Swiss COVID, so this has been activated, and this is also using the Google's exposure notification API. For the attacking laptop, this is a standard Ubuntu installation, 2004 LTS. The important thing is that the laptop needs to have a Bluetooth adapter that supports dual mode transport. So this means supporting BR-EDR and LE. And it has to be a Bluetooth 4.2 and above so that we can use the cross-transport key derivation protocol. So to demonstrate the attack, I'm going to use a modified version of btmgmt, the Bluetooth management tools from Bluez. This was modified to display more information, but otherwise the functionality is identical to the official version. So I'm running this as root. There are 3 steps in this attack. Chain 1, the first step is to obtain the identity address of the target phone. The second is to extract the identity resolving key from the phone, and the third is to just do a scan on a target phone to see the rolling proximity identifiers. Okay, so because of the issue with Oppo's Bluetooth implementation, it puts the phone constantly in a discoverable mode, even when you are not in the Bluetooth setting page or you're not trying to pair with another Bluetooth devices. Because it's in a discoverable mode, it's easy to find just using a scan on the BR-EDR. So this is simply done by typing the find command, and we see here that Oppo Reno 2Z is among the devices found by the scan. And the address here is the identity address, as we can confirm by looking at the setting page of the phone. As you can see on the screen of the phone, that the Bluetooth address here matches exactly what's been displayed on the laptop screen. Before we execute the next step to extract the IRK, we first try to scan for the exposure notification RPI first to see if we can to check whether the app is actually running properly. So to do this, I first turn on the EIR data so that this btmgmt will display the RPI, and then I just use the find service command with the UID FD6F, which is the UID used by the exposure notification. So we see here that it found several advertisements, but they're all identical in the sense that the Bluetooth address that is used to advertise, they're all the same, and the rolling proximity identifiers here are all the same because they all came from one device. There's only one device running the exposure notification in this experiment. Next, we're going to execute a pairing command between this laptop and the phone. We do this by the pair command, but we specify the option -C3 to indicate that this laptop does not support input or output, which will then force the pairing with the phone to happen over the JustWorks protocol, and that would proceed silently, so we will not alert the user of the phone. I will first just copy over the address. You can see that the pairing is successful, and we did not see any pairing confirmation dialog on Oppo's phone, like what you would expect when a pairing request comes in. And this is essentially due to the JustWorks method that we're using. And the second thing to notice is that the RK has now been sent over from the phone to this laptop, which means that this laptop now will be able to resolve the random private addresses used to advertise the RPIs. So we are going to now do another round of scan and see if we can associate the RPI with the identity address. As you can see now, because the laptop now has possessed the IRK of the Oppo phone, the random address that was used previously, in the previous scan, 5B, 9F, 5E, and so on, is now resolved to the identity address of Oppo. And we can check that the RPI are identical in these two broadcasts, which indicate that they actually do belong to the same phone. So there was, and in addition to the fact that there was no other phones running the exposure notification advertisement. So what we have shown here is essentially a very simple exploit to de-anonymize the rolling proximity identifiers for certain types of phones that happen to have that vulnerability.